Many cloud architectures and environments are designed to host internet-facing web applications and services. Once an internet-facing application or resource comes online, it can be as little as a few minutes before external actors start testing those applications for exploitable vulnerabilities. To learn more about these types of attacks, I recommend you become familiar with the OWASP Top 10, which functions as a high-level list of the most common security risks that web applications may be susceptible to. Web application firewalls, or WAFs, are designed to sit between a client and an application to inspect application HTTP traffic and determine if the traffic patterns signify exploitation events. WAFs are then set up to block this type of traffic. Most WAF products continuously update their rule sets and allow you to tune them to add your own custom rules or manage false positives. There are a few different ways of incorporating WAF protection to defend against application-level exploits. Cloud-based WAF products such as Akamai or Cloudflare are set up so that clients can point to them as an entry point into the application. These are designated as Content Distribution Network or CDN providers. However, they provide WAF capabilities as part of their offering. Cloud providers such as AWS also provide this type of service natively. AWS WAF can be placed in front of public-facing application services such as CloudFront API Gateway or EC2-based workloads in a transparent manner so that application endpoints don't need to change. A WAF appliance or network-based WAF can be deployed into a VPC as a set of EC2 instances to protect EC2-based application traffic. Example vendors include F5, Fortinet, Imperva, Cisco, etc. Now these can be costly and complex to implement and what you would typically find in a traditional data center environment. Now host-based WAFs are products that attempt to provide similar defense but are deployed as part of a web application server instance. And one of the drawbacks to a host-based WAF is that it can impact the resource consumption on the instance. What about serverless? Serverless applications also need to be defended. Many products offer capabilities to defend serverless applications from application exploits, such as those running in Lambda. Example products include Aqua, Twistlock, and PureSec. Depending on the application architecture, the method of defending the application may vary. Regardless of the type of WAF implemented, a few best practices to consider. Set up the WAF with identical configuration in lower environments for testing to ensure that your applications still work as expected in production. Fine-tuning may be required to rule out false positives. Perform penetration and exploit testing against applications to ensure that the WAF defends as expected. Test both with and without the WAF to get a better understanding of defensive capabilities. Enable WAF logging and export logs to your security monitoring tools. Identify all public endpoints for your applications, including CloudFront, application load balancers, and API gateway. If your application is exposed to the internet with other methods, consider moving your application behind these mentioned services. We will now explore using the AWS WAF product to defend a web application.